How binarized networks work, and why they'll be big for AI in 2020. Neural networks are great, but they're still being held back by cost and energy, but binarized networks might fix that. The concept of neural networks first emerged more than 40 years ago when scientists experimented with mathematically modeling the functions of the brain. They worked out they could make a mechanical implementation of the neural network that could be trained to recognize patterns and classify data, for example recognizing whether a video contains a cat or a dog. Over the past decade, the complexity and capacity of neural networks has increased sharply. Coinciding with the extraordinary growth of cheap and easily accessible heavy-duty supercomputers and graphics processing units, GPUs, they have come to the fore as the de facto network brain of choice for problem solving, pattern recognition, and anomaly detection. Today, organizations use them for sales forecasting, customer research, data validation, and risk management among many other applications. Despite this adoption, there are drawbacks to neural networks, drawbacks that limit their potential. The Holy Grail is a neural network that can analyze information quickly without being expensive and energy greedy. Achieving networks that fulfill those criteria is a challenge, and one that must be overcome if we are to spread the benefits of neural networks closer to the edge of IT and communication networks, and to endpoint devices. As a result, one alternative that many organizations are looking into is binarized networks. They are a fairly new technology, but they're likely to make a significant impact in 2020. To understand why, we need to grasp how both types of networks work. How neural networks work. Neural networks comprise multiple layers of weighted sums. Each weighted sum adds up to a number that either indicates that this data likely exhibits some feature, or likely that it does not exhibit a feature. These layers combine, for example, raw image data into features, and recombine those to eventually reach an answer. To put that in simpler terms, for more on this story, visit the news article link.